In the previous video, you already saw how easy it is to communicate with Internet of Things devices and PHP using MQTT. While publishing is quite straightforward, subscribing to an MQTT broker with PHP can be a more complicated process. This complexity is due to the need to maintain an active connection and continuously listen for incoming messages. However, as you saw in the previous video in Laravel, we have commands that can be run continual. In a production environment at the server level, we can configure Supervisor or Laravel Octane to implement a subscribed system capable of handling many devices. Supervisor is a process management system that allows you to monitor and control services on your server. It is useful for keeping PHP script and other service running in the background. Subscribing requires maintain an active connection and constantly checking for incoming messages. This is achieved through an event loop, which reads data from the open socket. This loop needs to run continuously to ensure that all messages are received without delay. Messages can arrive at any time, which means your application must be ready to handle them without blocking the main execution process. This accomplishes it using callbacks, which are automatically triggering when a message is received. This mechanism allows your application to respond quickly to events without slowing down other operation. Subscribing to MQTT topics in PHP is more complex compared to publishing, because PHP is traditionally designed to handle short-lived scripts, such as those triggered by HTTP requests. Once a PHP script finishes executing, all resources, including network connections, are released. However, MQTT subscriptions require a persistent, long-running process that continuously listens for incoming messages. This goes against the classic PHP execution model, which means you need an alternative approach, such as running your script as a background service. By default, PHP doesn't maintain open network connections after the script ends. To keep an MQTT connection alive, you must run the script in a blocking loop that continuously processes incoming messages. PHP also lacks native support for multithreading or asynchronous I/O. Fortunately, there are extensions and tools that help overcome these limitations. For instance, Laravel Octane boosts performance by booting your Laravel app once and keeping it in memory. It supports runners like Swool, Roadrunner, and FrankPHP. OpenSwool is a C-based PHP extension that adds support for asynchronous and concurrent programming, including TCP server capabilities, which are fundamental for building MQTT-compatible systems. While it is technically possible to build an MQTT subscriber in PHP using these tools, managing thousands or tens of thousands of concurrent MQTT connections is more naturally handled by technologies designed for this purpose. That's why, instead of complicating things within PHP, I propose using a dedicated microservice, written in a more suitable language like Go, for handling MQTT subscriptions. This aligns with modern IoT cloud architecture, which relies heavily on independent microservices. Laravel will remain responsible for managing business logic, storage, and web interfaces, while the MQTT microservice will focus solely on real-time message handling, each part doing what it does best. I've prepared a microservice in Go for this course, which handles the MQTT communication, while also interacting with Laravel via webhooks. By decoupling this service from Laravel, we gain the advantage of being able to scale it independently as needed. For example, one day you might have 1 million devices communicating over MQTT. In that case, we could host this service on a separate server from Laravel. I won't go into technical details about the service right now, but the complete source code is available on GitHub, and I've also prepared a few diagrams to give you a clear idea of how everything works. As the course progresses, I might add new features to this service. The architecture is modular, and since the end user doesn't need to work directly with Go, all configuration and operations are handled through Laravel. The Go service also includes an API, which allows it to send everything Laravel might need, such as metrics, logs, and more. Additionally, the Go service can work with any MQTT broker. All you need to do is define the desired broker in the environment file. The service has its own database where it stores messages, webhooks, and possibly other data I'll add later. It also supports various databases. For example, you could configure it to use MongoDB. For now, I'm using SQLite. Now let's see how to use this microservice in practice. This hands-on approach will help you better understand each step and what happens behind the scenes in an IoT cloud system. Indeed, some processes are fairly complex, but we'll go through everything step by step. We'll start with the assumption that you are the owner of an IoT cloud platform, and you're acting as an administrator with access to the system settings. Now, the first thing we'll do is set up a webhook that allows users to pair their devices with the cloud. The first step is to add an MQTT microservice to the config services, where we will include the setting for the microservice. Now, and so we can configure the service address and an API key in the env file if needed. Now, after this, we can create a webhook controller and a service. Here we have the controller, here a webhook microservice, so we can use direct webhook management in the browser or via API from a mobile application. We also use the helper created in the previous video to detect if the request is made via API or browser. Of course, in the routes we have the necessary routes both in web and API, and for direct management in the browser, a Livewire component. Now I will start the microservice directly from Goland. I have set up a working directory here, and now I just need to run the service. In Laravel, access the webhooks page and see which webhooks are already in the microservice. If for any reason the service is offline, Laravel will indicate that it is offline. Now I will add the edit and delete functions. For now, if we press delete or edit, only this message appears. The delete function is quite simple. It is enough to call the function from the microservice. Because I like Livewire, I added a modal component from FluxUI to have a confirmation pop-up. Now I will introduce the create webhook function, which will appear in a modal, and the edit webhook function. Additionally, I have updated the view to display all the data. Now let's move on to the pairing process. As an admin, I will create a webhook that the user can use to connect the device to the cloud. Now the user is creating a node. In production, the logged-in user will be automatically associated with their node, or as it is now, where an admin chooses the user for the node. I sent a post request from Insomnia to the microservice to subscribe this topic. Later, we will also add this to Laravel, but for now, I am subscribing from here. Once the client receives a UUID for this topic, it informs Laravel via webhook, and Laravel, through a pairing controller, verifies which user the device is associated with. If it finds a match, it will write the status confirmed in the user node mappings table. I prepared a simple test with an ESP32. Immediately after the internet connection is made, it contacts the broker, and then the webhook informs Laravel. A match is searched for in the database, and if found, we will see the status confirmed. After pairing, the device can work normally, connects to the broker. It sends data, telemetry, status, etc. to the desired topics. The current code for Laravel and the microservice in Go can be found on GitHub. Links are in the description. I chose to include my voice using AI in this video because I believe it's much easier to understand than my accent. Don't forget, if you have a specific topic you'd like me to cover about Laravel and IoT, leave a comment and it will be added to the to-do list.